Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the second question from the final examination which was written in the year of 2024. Yes guys, we are doing mathematics paper 1. It's a DBE exam. And please expect a total number of 11 videos since the question paper had 11 questions in total. And that simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay, we are told that the first term of an arithmetic series is 7. Okay, so A is equal to 7 and the common difference of the series is 5. Okay, so the difference is equal to 5. And then we are also told that the series contain 20 terms in total. So n is equal to 20. First question says calculate the sum of the series. We do have a formula that says Sn is equal to n over 2 into 2a plus n minus 1d. All I just need to do guys is to just substitute the values of a, n and d. So n is equal to 20, a is equal to 7, that's 20 minus 1, and the difference is just equal to 5. So the values of a, n and d are already substituted, and hence the sum of the first 20 terms will be equal to, that's 2 times 7 plus 20 minus 1 times 5. The sum of the first 20 terms is just equal to 1090. So the sum of the first 20 terms is 1090. Okay, and then now we are told that the original arithmetic series is extended to 75 terms. So now the number of terms is no longer 20 but is 75. Okay, let's update that as well. And then the sum of these 25 terms of the series is equal to 14,400. So the sum of the first 75 terms is 14,400. Using sigma notation, write down the equation for the sum of the terms added to the original series. The sum of the terms added to the original series. Okay. Remember that guys, we have an arithmetic series over here. So initially we had T1 until T20, and then some terms were added. We ended up having T21 until T75. So they just want us to find the sum of these terms which are added. But remember that guys, we were given the sum of the first 20 terms and also the sum of the first 75 terms. So I can simply say that the sum of the first 75 terms, the sum of all the terms, is basically equal to the sum of the first 20 terms plus the sum of the next 55 terms. Remember that guys, 75 minus 20 will give us 55. So basically there are 55 terms which were added. So the sum of the first 20 terms plus the sum of the next 55 terms. We are told that 75 terms is 14,400, and whenever we calculated the sum of the first 20 terms, we got 1090. So for me to find the sum of the next 55 terms, I'll just say 14,400 minus 1090. This will give me the value of sum of the next 55 terms to be equal to 13,310. So this is the sum of the next 55 terms. Are you together, guys? So all I need to do is to simply express this in sigma notation. So sigma, we always have Tn over there, the general term, and then over here we'll simply have our sum. But I must only represent the terms that were added in sigma notation. I know that their sum is just 13,310, and I know that there are just 55 terms. All I need to find now is the general term for all these terms of an arithmetic sequence. Né? How can I do so? I know that Tn is equal to a plus n minus 1d. A, the first term of this sequence is 7, n minus 1, the difference is equal to 5. The 7 plus 5n minus 5, and hence the nth term is just 5n plus 2. This statement over here will generate for me every term that I need in the series. So after finding it, I'll just substitute it over there. I'll have 5n plus 2. So now I've represented the sum of the terms that were added to the original series. Okay, let me write it here. So the sum of the terms that were added, remember that the terms were 55 and the general term is just 5n. It's 5n plus 2, and the sum is just 13,310. Remember that, guys, for us to find 13,310, we simply use the fact that the sum of all the 75 terms is 14,400. But initially we calculated the sum of the first 20 terms to be equal to 1,090. That means the sum of the next 55 terms that were added will simply be equal to 13,310. That's how, guys, we tackled 2.1. Now let's go to 2.2. 2.2, we are told that the sequence of the first difference of a quadratic number pattern is given. Remember that, guys, a quadratic number pattern has two differences. The first difference is arithmetic, and the second difference is the one that is common. So over here we are told that this sequence represents the first difference of our quadratic pattern. Yeah? So since we are not given the first term in our quadratic number pattern, I can assume that, okay, let's just say the first term is equal to x, né? And then we can find the next terms of our quadratic number pattern. Remember that we are told that we have 1, 3, and 5. So the common difference will be 2. The common difference will be 2. Then if we have 2, that means over there we simply have 7. So how can I find the next terms of my quadratic sequence? I'll simply say first term plus the difference, that's just x plus 1. And then over here I'll have x plus 4. And then I'll have x plus 9. And then I'll simply have x plus 16. So these, I'm assuming that these will give me all the terms of my quadratic number pattern. So now let's answer the first question. If the 99th term of this quadratic pattern is equal to this, calculate the value of the 98th term. Okay. Let me show you guys how a quadratic number pattern is structured. Né? You'll get the first term, second term, third term, fourth term. This will go on and on until maybe the 98th term as well as the 99th term. Né? Okay, Now let's find the first difference. I'm going to call it D1, D2, D3, and then the term over there, it will be simply D98. How do I know that? Please note that, guys, the difference between the second term and the first term will give us the first term of the first difference. So the difference between T3 and T2 will give us T2 of the first difference. The difference between T4 and T3 will give us D3, rather the third term of the first difference. So guys, do you see the pattern here? Between these two numbers, we will take the position of the smaller number between the two. So between T1 and T2, we'll get T1 of the first difference. Between T3 and T2, we'll get T2 of the first difference. T4 and T3 will get T3 of the first difference. That means between T99 and T98, I'll simply get the 98th term of the first difference. Are you together? So remember that, guys, for me to find the 99th term, I simply need to say the T98 of my quadratic sequence plus the 98th term of the first difference. So therefore, for me to find T98, I just need to say T99 of the quadratic minus the 98th term of the first difference. So this equation will simply give me the 98th term that they are looking for. So for me to find the 98th term of the quadratic sequence, I must first find the 98th term of the first difference. And how can I do so? Remember that, guys, I'm already told that this sequence 1, 3, 5, etc. represents the first difference, right? So I just want to find the 98th term of this sequence. I'll simply use my general formula. It says Tn is equal to A plus n minus 1d. I'm looking for T98, so that means n is 98, right? A is equal to 1, and then n, that's 98 minus 1, the difference is just equal to 2. This will just give me the value of the 98th term. 1 plus 98 minus 1 multiplied by 2. The answer is just 195. So the 98th term, guys, is just equal to 195, the 98th term of the first difference. So this term over here will simply be equals to 195. I already know the terms over there. There's just 1, 3, and 5. So for me to find the 98th term of the original sequence, I just need to say T99, which was given to us as 9632 minus 195. 9632 minus 195. The answer is just 9437. So the 98th term of our sequence is 9437. Ne? How did I get to this solution, guys? Remember that the first term of the first difference is between the first two terms. The second term of the first difference, or rather T2 of the first difference, is between T3 and T2 of the quadratic. The third term is between T4 and T3. Are you together? So these guys forms a pattern. The first term is between T1 and T2. The second term is between T2 and T3. The third term is between T3 and T4. Are you together? So that means the 98th term will be between T98 and T99. Are you together? So for me to find the 98th term of the quadratic sequence, I must first find the 98th term of my arithmetic, or the 98th term of the first difference. Are you together, guys? After finding the 98th term of the first difference, I'll simply subtract it to the 99th term for me to find UT98. That's how, guys, we're supposed to tackle question 2.2.1. Now let's go and answer the 5-mark question. It is further given that the third term of the number pattern is 32. Determine the general term, which is the nth term of this quadratic pattern. Yeah? Okay, remember that, guys. How did I find these values? These are the values of my quadratic number pattern. If the first term of the quadratic number pattern is equal to x, for me to find the next term, I just need to say x plus 1. Are you together? So I'll end up having x plus 1. Yeah? And then for me to find the next term, I'll say x plus 1 plus 3. This will give me x plus 4. And then x plus 4 plus 5. This is just x plus 9. And then x plus 9 plus 7. That's just x plus 16. So these represent the first 4 terms. The first 1, 2, 3, 4, 5. The first 5 terms of our quadratic number pattern. Yeah? But, guys, we are told that x is the third term is 32. So basically 32 is equal to x, our x plus 4. We generated our own number pattern in terms of x, right? So 32 is just equal to x plus 4, and therefore x is just equal to 28. So the new sequence, guys, with numerical values will basically be 28, and then x plus 9, x plus 1, that's 29, and then 28 plus 4 is 32, but we were already told, yeah? And then we'll have 28 plus 9, 28 plus 9 is basically 37, and then 28 plus 16 will give us a 44. So these guys will form our quadratic number pattern. Eh? The difference between these 29 minus 28 is 1. Over here I'll get a 3. Over there I'll simply get 5, and then I'll get a 9. Not a 9, man, but a 7. This is equal to 7. And then the second difference is common. That's 2. Ne? Remember that, guys, for me to find the nth term of a quadratic number pattern, I just need to say 2a is equal to the second difference, and then 3a plus b is equal to the first term of the first difference, and then a plus b plus c is equal to the first term of the sequence. Ne? Okay, so 2a is equal to 2, therefore a is just equal to 1. 3a plus b is equal to 1, that's 3 times 1 plus b is equal to 1, then b is just equal to negative 2. And then I'll have a plus b plus c is equal to 28. A is equal to 1, b is negative 2, then c. Therefore, the value of c is just equal to 29. And hence, the nth term is just equal to an squared, that's n squared, plus bn plus c. So this general term over here will simply give me the terms in my sequence. Let me confirm whether it's correct or not. Let me just find the third term. So I'll have 3 squared minus 2 times 3 plus 29. The answer is 32. Okay, let's go and find the 99th term. 99 squared minus 2 times 99 plus 29. You still get this term over here. So this guy is valid, guys. Now, I know that there are many ways, guys, to tackle this question, but I prefer doing it like this. Let me take you back, guys. Now, remember, we were only given the first difference. This was what we were given. Are you together? So I have the first difference, and I can also find the second difference. Now all I need to do is to find the quadratic sequence. Since I didn't know the first term of my sequence, I said let the first term to be equal to x, and then the second term will be x plus 1. The third term will be x plus 1 plus a 3, we'll simply get x plus 4. X plus 4 plus 5 will get x plus 9. Then x plus 9 plus 7 will simply give us x plus 16. Are you together? But we were told that the third term of the sequence is 32. So x plus 4, our x plus 4 is basically equal to 32. That's why we used it to find the value of x. X plus 4 is equal to 32. That means x is equal to 28. So if I know the value of x, I can simply find the numerical values of these terms. That's what I did over there. Are you together? So now if I have the numerical values of my terms, I can simply find the the nth term. For me to find the nth term, remember that this is a quadratic number pattern. I need the value of a, I need the value of b, and I need the value of c. I know that 2a is always equal to the first term of, rather 2a is equal to the second difference, and then 3a plus b is equal to the first term of the first difference, and then a plus b plus c is equal to the first term of our quadratic pattern. So we found a, we found b, and we found c. We just substituted them on this equation to find our answer. That's how, guys, you're supposed to tackle this question over here. Please do stay tuned and wait for more videos. Thank you.